Hey there, you ready to learn about another type of new number that we use in mathematics? So you're probably very familiar with the real numbers. That refers to the number line, all of the negative numbers and all of the positive numbers. And real numbers are useful to solve equations like x plus 3 equals 8. Well, this equation has the real solution, x equals 5. But a few hundred years ago, mathematicians realized that real numbers were not enough to solve every type of equation that we might want to solve in mathematics. Like if I need to take the square root of a negative number, there is no real number that we can use for that. So we defined this imaginary unit called I, which has the property that I squared is equal to -1. And then to take the square root of a negative number, we write it as an imaginary square root. So the square root of -4, using this principal root, would be 2i. Now, I don't really like the term imaginary numbers. That's just a historical relic that comes from the fact that we already had a name for the number line. We called that the real numbers. So when we created a new type of number, they were called imaginary. But remember that imaginary numbers are not fake, just as real numbers are not fake. Even though these are concepts that were created in the human brain, they're both valid tools that we can use in mathematics. So another way that we could think of the imaginary numbers is maybe think of them as existing in another dimension that we could run perpendicular to the set of real numbers. So just as there is a real number line, there is an imaginary number line that has multiples of our imaginary unit. Now, what happens if we put these two number lines together so that we have a multi-dimensional space? Like if we wanted to combine together the real number 5 and the imaginary number 2i, well, we would get a new type of number that we could write as 5 plus 2i. So these new types of numbers that we get when we combine the real and imaginary dimension, those are called complex numbers. So the formal definition of a complex number is it's a number that is written by combining together a real part and an imaginary part. And we see some examples down here. So any complex number is composed of a real part. The real part of this complex number is 4, and we would say that the imaginary part is -3, which is the coefficient in front of that I. The real part of this example is 1/2, and the imaginary part is 1, because when we see this I written by itself, another way we could think of that is it's just 1 times I. And in fact, even numbers that don't seem to have a real part and an imaginary part can be considered as complex numbers, just with one of those parts missing. So the real number -8 could also be considered as a complex number, just where the imaginary part is 0. And the imaginary number 4i could be considered as a complex number where the real component is 0 and the imaginary component is 4. So now that we've got this new space of numbers we can work with, these multidimensional complex numbers, let's talk about how we can simplify expressions involving complex numbers. We want to combine like terms just as we would when we're adding polynomials, except there's a slight difference in that the symbol I is technically not a variable because it's not a value that changes, but it always has the same value. I represents the square root of -1. But other than that, we can treat this as if it was a polynomial, and we're going to combine together the imaginary parts and combine together the real parts. And we'll keep these two parts separate. So if we do 3 minus 7, that would give us the real component -4, and 5i plus 7i is the imaginary component plus 12i. If we're subtracting one complex number from another, as we see in example 2, remember that a negative sign outside of parentheses needs to be distributed to both of the terms inside of the parentheses. So negative times -1 becomes +1, and negative times +3i becomes -3i. Then after that, we can combine the like terms. So if we combine together these imaginary components, +3i and -3i cancel out. If we combine together the real components, 8 and +1, that gives us the real component +9. And another way that we could write 9 plus 0i is just +9. Let's do a couple more examples real quick just to make sure we're understanding. So first, let's distribute this negative sign to both of the terms inside our parentheses. That will turn this +5 into -5 and -2i into +2i. Now, to combine these terms together, we want to combine the imaginary parts. 8i plus 2i is 10i, and -2 plus -5 gives us -7. One more example here. We've got a negative outside of these parentheses that we need to distribute. So that will turn this real component into -7 and this imaginary component into +8i. Then we have two imaginary terms we can combine together. +8i minus I gives us +7i. And from our real components, -7 and -3 gives us -10. So that's a quick intro to this new type of number, the complex numbers, which we get by combining together the real number dimension and the imaginary number dimension into this new space. If you would like to see a few more examples adding and subtracting, we'll work through these on here. So these expressions are a little bit longer, but the method is still the same. We want to combine together any real parts and any imaginary parts separately, also noting that subtraction outside of parentheses implies we need to distribute that negative sign to both of the terms inside of the parentheses, which will just reverse the signs inside the parentheses. Positive would become negative, and a negative would become a positive. Let's do that again down here. That would turn this into a +1, and this into a +8i, or imaginary 8. Now we want to match up all of the like terms, our imaginary terms, which would be 3i plus 8i, so that gives us 11i, and then subtracting 1i gives us 10i. When we combine together -4 and +4, we get 0. So this complex number has a real part that's equal to 0. So another way we could write this is just 10i on its own. Finishing example 6, let's combine together our real components. +8 plus 1 plus 4 gives us +13. And when we combine together these imaginary components, we have -8i plus 8i. Well, those two terms cancel out. That would just give us 0i. But then we still have one more imaginary part here, negative 4i. So adding and subtracting complex numbers is not that much different from adding and subtracting real numbers, just that we have to keep the real and imaginary parts separate. But multiplying and dividing complex numbers is a bit more interesting, and stay tuned for that in another video.